Next we have Zhengnan presenting her research, and she is also a fairly new PhD. How many weeks? 4 weeks?
Yeah.
5 weeks?
6 weeks.
6 weeks. 6 weeks. So again, amazing that you've been able to pull something together to present. I will let you take the stage.
So, hi everyone, I'm Zhengnan, and I commenced my study for 6-7 weeks. And my research topic is Synthesis 7, how can historic data can be leveraged to achieve more sustainable future projects. And first, I want to introduce myself. I obtained a bachelor and master degree of architecture, and I worked as an architectural design assistant into real estate companies for the project management. And back to my research background, we all know that the greenhouse gases is released during the supply chain of the materials, which is contributing to the carbon emissions in the AEC sector. So if we can renovation, it will save between 50% to 75% to the carbon emissions compared to the construction of an entirely new buildings. So it's obviously that the most sustainable building is the one that already exists. And so if we can use the existing buildings during the 1960s to 1990s, which is at the end of their lifespans, maybe it will be a large data set for large spatial models, especially for these buildings, lack of the historical or the cultural significance, because all of them maybe will be demolished in the common practice. And we can imagine that if we have a large spatial models, like the Google's large language models, but the large language models deal with the text, and the large spatial models can process the spatial or geometric data of the existing buildings. And if we click each buildings in this model, maybe it will show us the material volumes of them, and we can reuse them in the future projects. And we all know that there are some technologies like the laser scanning and the point cloud approaches that we can use that to build the models for these buildings, but maybe they will be time-consuming if we need to process a large amount of existing buildings. So if we can use the machine learning models, it will help us to build the data sets more easily. And after the literature review, we have 3 aspects in this topic. Like the first is some researchers already try to transform the raster images into the vector drawings, and some of them also use the CAD drawings and transform them into the BIM data for the waste management systems, but maybe they ignore the structural drawings or details, which is important to find out which materials we used in these buildings. So maybe we can combine these original documents and the hand drawing documents to create a BIM data. And also some previous research just focused on the waste management systems for demolition buildings rather than for renovations. And also lack of guidelines on the requirements of using recycled construction and demolition materials. So a research gap obviously exists, like how to convert the hand drawing documents into BIM data for material reuse under the national and local regulations. And so the research questions will divided into 3 parts. Like the first, what factors will promote the architects and clients in demolition or renovation, and what materials have been used and in what quantities, and how to integrate regulations to assess the material's strengths. So the main objective will developing a model learning model a machine learning model to use for the transforming images into BIM data. And it will involve 4 conceptions, like first we need to scan the original documents into the raster images with different styles, and then we maybe use the optical character recognition to recognize each part of the drawings and try to train and test the machine learning model to transform these elements into IFC format, and then for future quantity takeoffs. And now we obtained 4 projects in Adelaide from an architecture museum, and this is one example, like the plan, the sections, and elevations details. Maybe in the future, the research needs will divide into 3 parts, like access to the original 2D drawings from Adelaide, and we will try to identify a case study building for test and the machine learning model, and maybe there will be some possible interviews with our industry partners to find the factors which promote the demolition or renovation. And yeah, that's all. Thank you.
Thank you. Questions?
Thank you very much. I think this is such an interesting problem. And it's really interesting that you're saying there's been more conversion of CAD into BIM than there has from all the resources on hand-drawn things. I think it's, I'm just thinking aloud here, but it seems like a really good first step to actually take the information that's on the drawings. What I'm hearing a bit from building partners is that to reuse stuff, I mean, I think you're talking about renovation more than actually taking stuff and reusing it elsewhere, but that they need this kind of verification of as-built and quite a lot of depth of information about, particularly if it's components as well as materials. So, but I guess, in your PhD, you could, even if you got to that step and started to speculate on how you would enrich that data to make, to look at the value of the things that are incorporated in the building and how they can be reused beyond that. I think that would be really interesting. Have you thought about the difference between the drawings and the what's actually there in the building?
Maybe no. Yes, I will try to figure out it.
Further questions? Tim looks like.
It's an interesting topic, and many researchers, I think globally look currently at how do you maybe build a constrained repository of existing building components and materials as well. So, I think Jane's comment is, super important to look at the kind of discrepancy between what has been drawn and what has been built. So in that sense, it's kind of also, I think you should maybe have a look at methods of reconstruction. There's a lot of work that is also happening both from two-dimensional, data sets to three-dimensional data sets, and how to extract information, because not everything is also in the drawing. Even if you would then do an as-built survey of a building or of an object, you can't see through certain things. So there's something about predicting what might have actually happened according to the time when that was built. Yes. And I think there's a bit of research that's out there you could have a look at as well. The other thing is that, if it is about reuse, there's some quite interesting work that came out of TU Darmstadt, because of the change of change of regulations, certain things just can't be used anymore. They looked in particular at concrete, because what went into the mix is actually completely non-compliant anymore. So even things like that, and then to compare what has been built to what the legislation was then compared to what it is now, would be really interesting, I think, additional layers
Yes.
to that inventory that you're building.
Yes. Thank you.
Andrew.
So this is a new concept, and that's not a criticism. Okay.
Yeah.
So
Thank you.
we've worked on quite a lot of redevelopment sites around Sydney. So there's already a lot of existing case studies that you could mine, where we've had to go through drawings, get LiDAR scans, and effectively do all of this research into an existing building, just for us to be able to do the redevelopment work that we need to. And these are like significant buildings in Sydney, and I'd say all the partner investigators have probably had to do some work along these lines. So I think there's quite a lot of information out there that you could get from us. I think that the problem is that they probably exist in projects that are sensitive in terms of transport, but there's definitely means there to get that information out and start inferring, start learning from what we had to go through, because I imagine we all had to go through the same thing, and it really does come down to that, like 80% of the building matches the drawing, 20% doesn't, and a good example is like Wynyard Station. That 20% was the grid, which is quite significant. The grid did not match the drawings. So I'm putting my hand up to say that I want to provide that, and I'm kind of encouraging the other partner investigators to also put their hand up for that as well.
Yeah. Thank you.
Great. Well, I think it's a really great research topic in itself. And I was also just commenting on it in terms of what's actually required for a redevelopment of a project and a renovation of the project. It's not only understanding the as-built, which is crucial obviously as well, but it's also the condition of the as-built. So a lot of pre-stressed concrete slabs, for instance, that are just cracked to beyond being used once you rip off the carpet, and then you suddenly have to invest much more money and energy to bring it up to a new code and standard that you can reuse it again. And it's also, you can only understand that building once you strip it to the bones. So you have to get rid of all the interior or all the linings, which have most likely changed from its original documentation in the 60s 5 to 10 times. Whoever's tenants, they just want to have the new interior fit out. So I think that is something, I guess, as a challenge for yourself, how you would implement this data, or how do you identify the data that is missing from your original set of drawings because of the evolution of the building and the usage of the building itself.
Yes. Yes, maybe.
Just a comment.
Okay, thank you.
Any further questions? You really can see it's late afternoon and everybody's tired. The extra $700 on the bar tab yesterday evening kicks in now. All right then, thank you for your presentation.
Okay, thank you.